All right, so rational exponents, that's what we're talking about today. Now, again, this should look familiar. Whenever you have a negative in the exponent, what does that mean? That's underneath a radical. You gotta use parentheses. Anybody can tell me, say it again. You flip the base, okay? So that basically means that this 5, 6 is gonna become what? 6 over 5, and what happens to the negative exponent? It turns into a positive exponent, okay? Remember, a negative basically flips that base. And since it's just to the first power, my final answer is 6/5. Okay? Taking that same concept with number 2, the negative exponent means I have to do what to the 3/4? Flip it. So it's going to become 4/3, and that entire quantity is going to be squared. And you square the top and the bottom. Sound familiar? Okay.
Square both the numbers.
You would, if it's in a fraction and you have the parentheses and it's on the outside, you do both parts. Very good. Now this one here, you can actually tackle this a couple of different ways. One way that you could do it is you could make your exponent positive first. How can I make this positive? One person. How can I make this positive? Person. Well, this is in the denominator, isn't it? So if it's in the denominator, it's negative. To make it positive, that means I have to move my x to the what? To the top. So this will become x to the positive 2, along with everything else that's up there. Does everybody understand that? So if it's already in the denominator, you bring it to the numerator. If it's in the numerator, you bring it to the denominator. And so then I'm just left with a y to the 7 at the bottom. Question? Yeah, go. You can get there in just a second.
That's all you do?
Wait, I'm not done yet.
Number 2, say that you never do 6 should
Yes. That's a very good question that she asked. She said if you can reduce it, should you? Yes, reduce your fraction. Okay? So, speaking of reducing your fractions, 20 over 30, can I reduce that?
Yes.
2 over 3. Now here, I have x to the 4th times x squared. Whenever you're multiplying with the same base, what do you do to your exponents?
Add them.
Add them. So this becomes an x to the 6th. And then when I'm dividing, you subtract your exponents, okay? So whenever you're multiplying, you add your exponents. Whenever you're dividing, you subtract. So what's 4 minus 7? -3. So this becomes y to the -3 at the top. Anytime you subtract in these cases, the number always, the number and the variable stay at the top. But can I have a negative exponent? So this moves to the bottom. So it's going to be 2x to the 6 over 3y to the 3rd. Don't you subtract?
You just put the exponent over the bigger number.
I don't think I'm following.
You got y to the 7 on the bottom and y to the 4 on the top.
Yeah, you can put it, yeah. That's probably how I would have done it, because I know I have 4 y's at the top and 7 y's at the bottom. If I take out a y from the top and the bottom, I'm still left with 3 y's at the bottom. This is the extra step. Yeah. Okay? Try the next 3 problems. Try the next 3 problems. Yeah. So in the first one, I don't like dealing with negative exponents, so I'm going to make them positive, which means that the x to the 9th comes to the top, and the x to the 3rd goes at the bottom, right? And so then from here, we would subtract our exponents. 9 minus 3 is 6. And so it's going to be 6x to the positive 6. So that should be your answer right here. You got that answer? Very nice. Now over here, I have a whole bunch of negative exponents, so I'm going to make all of them positive first. So the 12 stays where it is. The 8 stays where it is because they don't have a negative exponent one. Okay, so they stay where they are. But this a to the negative 2 is going to go to the top, and this a to the negative 4 is going to go to the bottom. And remember, once I change this position, the exponent becomes positive. This b to the 6th is positive, so it stays at the top, but this b to the 3rd, or negative 3, goes to the top. Okay? So, the way to think of it, if it's at the bottom, it comes to the top. If it's at the top, it comes to the bottom. Okay? So now, can I reduce 12 over 8?
Yep.
So be what?
4 over 3.
3 over 2, because both of them are divisible by 4, right?
Yeah.
Okay. Now, I would subtract my exponents. What's 2 minus 4? Negative 2. So this is the a to the negative 2. What do I do to my b's? Add my exponents, so I shall get b to the 9th. I can't have any negative exponents, so I need to bring that a to the negative 2 where?
Down.
Down. So my final answer is this. 3b to the 9th over 2a squared. Yes, sir?
Can you subtract your exponents first?
Yes. You can do that as well. And if you did that from the very beginning, you would have gotten negative 4 minus a negative 2, which gives you a negative. So basically, you can get to this point. So you can do that. Multiple ways you can actually simplify these. And the last one. Chris?
What's the square root?
No. Don't need the square root because it's not an equation that I'm dealing with. So I don't have to worry about square root. Right?
First you turn it into a fraction.
Turn it into a fraction, and when I do, wait, I don't think I'm going to say, what do you mean?
Turn it into x to the negative 9th over 1.
Okay, you can,
And then you just flip it.
and then you just flip it. And when I flip it, it becomes
Right.
positive. Yes, any number that's raised to a negative exponent is basically saying x over 1 or 6 over 1, so on and so forth. Questions on your exponents, negative ones. More specific. Now,
I wasn't
and
I
you
remember.
were
No,
still
I
responsible.
remember. I remember doing
You
something.
remember
I wasn't
that?
here when we did
Yep, 6 months later. All right, they should look familiar. Writing radical expressions in exponential form. Remember, the root is the denominator of that rational exponent. Okay, whatever's attached to the x or attached to your variable, that's your numerator. So here, this would be x to the what?
X to the 1/3. X to the 3rd. X to the 3rd.
Mhm. There's a 3 out there. We'll see that 3.
Yeah. 3rd.
Okay. So it's going to be x to the 3 halves. Because what is this?
Yeah, square root. Okay.
Square root. The root is your denominator. So if it's a square root, that means 2 should go at the bottom. That 3 is your numerator. Over here is going to be x to the what?
X to the 3/4.
3/4. You have a 4th root, so 4 is in your denominator, 3 is your numerator. This is going to be x to the, because it's a cube root, so the 3 is your denominator, the 5 is your numerator. Okay? Yes?
Would it happen as, x to the 4th and, square root, you have to simplify the fraction?
Yes, that's only if we're dealing with an equation. You're only, like, whenever you guys are thinking, like, whenever you guys say square root to me, I'm saying you're thinking, like, maybe you're thinking if it's an equation, you have to square root both sides or square both sides. That's only if you're dealing with an equation. We're just simplifying here. These down here at the bottom, these should look very familiar, okay? We did these when we were solving radical equations, okay? Method 2 was the way that we had done them before, but there is another way that you can do them, okay? You can still get the same, it's about the same, okay? So if you look at this example, I know that negative 32 can be written as negative 2 to the 5th power. Just think about a 2 to the 5th power is 32, make it negative. You can just multiply your exponents together, like how they did here. And then you see that 5 times 3/5 is just 3, because the 5's cancel out. And then it's just negative 2 to the 3rd power, okay? But that's essentially what, kind of like what we did before. Like method 2 is what we've done. We've written it in radical form. We took the 5th root of negative 32, and then we cubed it, okay? So this is the way that we've done before, but this is also another way you can do it. So look at example A. Do you want to do it method 1 or method 2?
1.
2.
1 or 2, I mean, honestly, it's the same. I'll do them both ways. Method 1. I need my exponent to have the same to have the same number as my denominator. So what number to the third power gives me negative 27?
3.
So this can be written as negative 3 to the third. And then I still have a 2/3 on the outside. So from here, I multiply 3 times 2/3.
3 cancel it, and left just square.
The 3's canceled, and I'm just left with a square. What's negative 3 squared? 9. Now, if I did it using method 2, I would need to write it in radical form. I have a negative 27 underneath the radical, but what root is this?
Square root of 3.
It's a cube root. The denominator is your root, which means this is being squared. What's the cube root of negative 27?
Negative 3.
And what's negative 3 squared? So no matter which way you do it, it's the same answer. All of these can be done without your calculator, guys. That's why I asked you if you knew your roots or your powers. Okay? Now, I want you to try B. I want you to try 25. My hint to you is instead of having that a decimal, why don't you try to write it as a fraction? Okay? I want you guys to take a minute and I want you guys to do B. With B, why don't we go ahead and make the exponent positive? To do that, what do we have to do? To make this positive.
Put 25 to the negative 2.5 over 1. Or under 5 would be.
So if I did this, if I made it into a fraction,
Yeah.
then I would flip it to make it positive. Okay, so now I no longer have any negative exponents. Now, how can I rewrite 2.5 as a fraction?
5 over 5.
5 over 2. Okay, now if you did this using method 1, you would have to ask yourself, what number squared gives me 25? 5. So this could be rewritten as 1 over 5 squared times 5 halves. What happened to the 2's?
They cancel.
They cancel out. So this becomes 1 over 5 to the 5th. And I went over this.
31.25.
31.25. So this is 1 over 31.25. If you did it method 2, you would still go up into this point, and then you would rewrite it as a radical. What will be my root if I wrote this as a radical? A 2, and it's the 25 to the 5th power. What's the square root of 25? So then you're back at that same point, 5 to the 5th, which is 1 over 3125. Questions on using rational exponents? This is old. None of this before.
Very difficult.
Flip over. You have an example that's already worked out where you're simplifying. Now realize, anytime you're parentheses, that means the entire quantity is being raised to this exponent. So that's why they have the 16, or they rewrote it as 2 to the 4th, raised to the negative 1/3, and even the y to the negative 8 raised to the negative 3/4. So you have an example already worked out. Okay?
I'll get it.
Not even giving it a chance.
It's no, like, how did you get?
Alright, so for A, we're going to make a little change to A, okay? We're going to change this negative 1/2 to a negative 1/3. So that way we can have some nice numbers here. Okay? Now I don't like negative exponents, so to make it positive, I basically have to flip this 8x to the 15th. So it becomes 1 over 8x to the 15th raised to the positive 1/3. Does everybody see that? I basically skipped that step by making it into a fraction and then flipping it. It's the same thing.
Wait, so you just changed it.
To change this to be a positive exponent instead. Right. Now, me personally, I want to use method 2 here. Okay? How can I rewrite this as a radical?
Cube root
Cube root
8x 15. And then there's just the first power, so.
Yep, it's just to the first power. So what's the cube root? 8.
2.
Yeah.
And then this is going to be x to the what?
3rd. 5th.
The 5th. Because all you do is basically 15 divided by 3. And then that will be your answer. Okay? Now it just takes some practice, some time.
Why
Yes.
did you switch it? I didn't think you said,
What do you mean switch it? What
like,
do you
from
mean?
making one third, like, from the original equation to the second.
Because it was a negative.
Right.
Whenever there's a negative exponent, you basically are flipping that whole number. So this is basically all over
How
1.
did you get the fifth?
So then to turn it positive, all you do is you just flip that fraction. That's where that negative became a positive.
So why did you change it, like, you took it one?
You never flip the number. I mean, think about all the ones we did, 1 through 6. We never changed -3 to a -1/3. You never flip the exponent. All you do is you're making it equal positive. The only thing that gets flipped is the base. Okay? It's the variable, it's the number that's attached to the exponent. The exponent itself never gets flipped. Yes.
How did you get the fifth power on the?
Because 15 divided by 3.
Okay.
Questions? Other questions? Now B. Still not as difficult, okay? Turn this into a positive, okay? When I turn this -10 into a positive, that means I need to do some flipping. But what gets flipped?
The number attached.
Well, you mean
Variable. Everything.
not everything, only the variable. Because only A is being raised to the -10th power. Not 243, just the A. So this becomes 243 over A to the 10th. All of this is being raised to the positive 2/5. Okay? Now you basically have to apply the 2/5 to the numerator and to the denominator. Okay? You want to do it using method 1 or method 2?
Two.
2. So that means 243, what's going to be my root?
5.
And then I'm going to square it. Now I went over, now I didn't do this example, but what is the 5th root of 243?
3.
3. And then you square it to get what? 9. There's your numerator. Is everyone okay with that? If you're, yeah? We're not there yet. We're not there yet. Everyone okay with the numerator?
Yeah.
All right. Now at the bottom, you have A to the 10th is being raised to the 2/5. Now we can do it the same way. I'm going to have a 5th root, and it's going to be squared. What is the 5th root of A to the 10th?
2.
A to the 2. I'm still squaring it. What's 2 times 2?
4.
Now again, this is just one way to simplify this. This is just one way. There's at least about 3 different ways you can do this. Okay? So what I want you guys to do, bless you, is I want you to take 3 minutes and do the bottom part of that paper. Take 3 minutes and do the bottom part, and then we'll check your answers after 3 minutes. So let's look at this last one. I gotta write this in radical form. 7 is gonna be what? It's gonna be the square root of y. Now, if you write this, okay, this is being a little bit redundant because the regular root is a square root, so you don't have to write that 2 in there, okay? And you don't technically have to write the 1 either. Over for 8, this is gonna be cube root of A.
Yeah.
And then the last one is gonna be what? Square root and to the 5th. Okay, no need to write a 2 there, it's already a square root, represents 2. Over here to write an exponential form is going to be x to the what?
5 over 2.
5 over 2, that is a square root. So remember, the root is the denominator. Over here for 11, that's going to be a to the
Third. 8 to the third is square. And 4 over 1. Or 1 over 4.
1 over 4. I can simplify this some more though. By doing what? don't both of these, aren't both of these being raised to 1/4 power? So this would be A to the 3/4 and then B to the 2/4, which is just 1/2. So you can keep going, and then this would be your final answer.
What was 9?
Look at your neighbor. And then the last one, you can rewrite it just like how we did number 11 and then simplify. So we're gonna have n to the what? 6/5, n to the 1, because 5 divided by 5 is 1, and then z to the 2/5. That will be your final answer there. All right? And then the last ones. How do I make this exponent positive? 1/3 to the second, which is 1. That's your final answer. No need for a calculator there. Even for this one, you don't need a calculator. What's my answer? 5. Now you can look at it as 25/5, or you can see, aren't these the same base? Which means you can subtract your exponents, can't you? What's your exponent right here at the bottom? 2 minus 1 is, so this is 5 to the first power. Looks the same way. And also think about it, okay, the bigger the problem, the bigger the numbers get, you know, the more likelihood you want to use your calculator, so even use that trick there. If these were 6s and this was a 3rd power instead, you know, you probably want to try to go to your calculator and do it that way. Let's go do this way. Over here, what answer did you guys give?
34, I'm sorry. Negative 34.
I got 8
This is negative 16. Because for this first part, what's being squared? Just the 5. It's not a parenthesis. So this is a negative 25, and over here, this becomes a positive 9. It's the same thing you guys have the issue with your calculator. You sit there and do negative 5 squared without a parenthesis, and the calculator gives you negative 25. And you write it down for some reason. Okay? Only the 5 is being squared here. Questions?